Okay, this week we are going to make a frame assembly by using the Inventor frame tools. And we have, in our example, we have four main parts. One lower profile, which is here, this one. We have two side profiles, these two. And also we have two different inside profiles for this structure. One is the long, the other one is the short profiles. As you see, we have the quantities in meters. It's just classical. When you use that tool, we do not have any profile so far within the quantities, because we are dealing with the profiles and we are just interested in the profile lengths. Here, what I'm going to do is, in this example, I will first open an assembly file. Also, I will create the basic sketch of this profile, but this profile sketch will be in a different part, and I'm not going to use that part in the part list. For this, I will just make out and delete the details of that part. It's only a sketch. There will be no mess of that one, but I do not want to see in the part list items. Let's start. From this point, what I'm going to do is I will just go for a new Inventor file. Let me close this one. I will open a new standard millimetric assembly and standard millimetric IPT parts. I will just first create the sketch part, which will be a skeleton model of our part. I will just define a skeleton model of our part from the outside of the dimensions, which I have seen here. For example, on the bottom side, we have 10,000 millimeters, and here we have 500 millimeters in height. Also, we have some restriction angles. These dimensions in the parentheses just shows us only the number, also only the reference tools. Also, you can see from the top side, we have some distinctive figures, distinctive dimensions. Okay. What I'm going to do is I will just make a new part file. I will just close this annotation. From this one, I will just save my part file as a frame skeleton, as here, but for a different frame folder. Frame, I will delete all the description. Frame skeleton. Again, as usual, I will just choose an origin point for my figure. For here, I'm going to select this point as my sketch origin. Okay. Let me clear. Okay. The next, what I'm going to do is I will just make it a little bit smaller and take it sideways to show you better to what I'm going to do. Again, I'll adjust two folders. I'll just close and adjust to see my profile here. Again, as usual, I will open a center point visible and XY plane visible. Start a new sketch by using the XY plane. Here I have a basic outline triangle. For this, I will just do something like this. For other side, I will make the copy, but for this, I will just create a new A line and turn it to construction. With right click, I will select the line first, the right click, and this is the construction. I will just make a copy of the mirror, select the entity, then select the mirror line, and choose the mirror line here. For this connection, I will use a constraint, which is the coincident line first, then the point at the end of this line. I will just, I'm sorry. Sometimes it will be easy to make this dimension first because it will just keep the length smaller here. For this, I will just use two lines, two dimensions, which is this dimension, the length here, it will be 10,000. And the height of our sketch or triangle of the frame here, which is 2,500. Okay, the next thing, I will just make this point on this line. I have the constraint, this point on this line. As you see, when I give the dimension of only two height and the length of the lower profile, with the symmetric condition, it automatically grabs. As you see, we have a similar dimension relationship between this line and this line. It is 5,000 millimeters. You can also use that one. The next thing, we will just create the profile information here. As you see, we also have another dimension at this point. And here, this profile from the top side, it just begins at this corner or the origin point, and it ends, which is 4,330 millimeters far from this point. For this, I will just create a line, an arbitrary line, just arbitrary line. And I will just make a trim and trim this point. And I would like to have a dimensional constraint, which is this point is far from this point with a linear dimension, which is 4,330 millimeters far from here. Okay. The next thing, also we have a copy on the other side. I will use for this the mirror button. The mirror, I select this entity, then select the mirror line, use this line, and apply and done. For here, we have two other profiles, which is directly going to this point. Here, what I'm going to do is, also, you can have this is the point which we are interested in. Actually, it is not deal with it. Yeah, okay, anyway. We can also have this point. As you see, when you just make the angular constraint, it is almost 30 degrees, the center lines. Here, I have two lines, which is this one. And here we have a profile length almost 1,000 970 millimeters after the trim operations. This is the length here. And I can just make this profile to this point. For this, I will just use not this one. I think this one will be okay. We have a perpendicular constraint, something like this, as you see. The next thing, we would like to have this point somewhere on this line. Probably it will be a midpoint constraint. Here, I would like to have this line end at this point. As you see, it is in the middle of this profile. What I'm going to do is I will copy this line on the other side by using the mirror command. I get the mirror, this line, select this line on the other side with apply and done. You can also create other dimensions as well. You can just delete if you want so. You can just give a 30-degree angular constraint here. Here we have, at this point, it will be something like this. This is a reference point. You can adjust this dimensional properties by using the precision to 1 digit. I'm sorry. Yes, this one. Also this one. You can just change its properties also in the sketch environment. This is our frame skeleton, and we will just use this plane skeleton for just adjusting the XY plane to our assembly. I will open all the visibilities of the planes before just starting to our assembly environment, because I'm going to use this assembly constraint, this part planes for construction, just adjusting the made conditions to our assembly. Okay, the next thing, what I'm going to do is I will just create an assembly with these profiles. For this, I will open a new assembly with standard millimetric IEM. I'm sorry. The next thing, I will open all the XY plane properties. As you see, we have these points are for our assembly environment here. Okay, the next thing, I will just recall my part here. And from this one, I will go to the frame folder and just get the frame skeleton part to my assembly. As you see, this is my part planes, and these are my part planes, and these are my assembly planes. I'll just make constraint in order to fix my skeleton model. Here, what I'm going to do is I will just use the same flush conditions for YZ plane to the assembly YZ plane, which is this one. I will use the origin under the origin planes with the assembly origin planes. For this, I will use the same flush condition. I will try to make the mates by having the normals to on each directions, okay? As you see, when I select the plane, my direction is outwards from the arrows that you can see here. I will use this YZ plane and this YZ plane with the flush condition. With OK, as you see, it is adjusted. The next thing, I would like to have my XY plane connected to the XY plane of the assembly. Here, what I'm going to do is I will constrain XY plane. Again, the same flush condition with the XY plane. With OK. As you see, we have this condition, but here I think I made a mistake. I would like to have the same solution with flush because it is the two construction, the two mates are the two constraints will be flushed. The next thing, I have just made my front view. I didn't fix this plane. For here, what I'm going to do is I have the origin on the top side, but this time I have the origin on the bottom side. For this, I will use a constraint tool. This time I will use this line to be on the origin of this point, which is the assembly center point. I would like to have these 2 points to be on these 2 points. Okay. Now what I do is I have the fully constrained. Then I will just close the visibilities of the planes. To have the sketch clear. Okay. Then I will just save my frame assembly, frame welded. This one. I will save. This is also better to renamed frame welded here. Next. What I'm going to do is I will just create the frames here. For this, I will use a design tool. And here I will use the frame tools. We also have some additional commands under this frame group. But first thing, I would like to have an insert frame members. First, I will just create a first frame members. Here, in the technical drawing, it has told me that all the profiles are ISO 10799-2 with the square profile with 100 to 100 with a 3 millimeter wall thickness. I will select that profile from this pop-up menu here. You can also go to all categories here. You will search the standard here with ISO. You will also go to this standard value, which I have seen here. 10,799-1. It is a square profile. You can also choose when you're designing. You can also choose different profile sections. These are the hollow section. I mean, the inside of our profile is empty as you see here. Okay. The next thing, we have the material, also the appearance of the material. You can also change to our material to steel, although it is defined with the cold formed welded structure hollow section. This is a welded and cold formed hollow section. This is another extrusion process. Here, the next thing, what I will do is I will just place my part according to the figure which I have seen here. Here, the first thing, I will just start from the bottom profile of our section. Here, I will open this time. I will open this profile and I would like to have this profile to be generated. Okay, the bottom one. And it is starting between these 2 points. One is this one and the other one is this one. Here you can use insert the member between points, which is this point and which is this point. When you just select 2 points, you will just create a profile. As you see, it has just appeared. But from the orientation menu, you can just orient your profile according to the figure here, which is X and Y planes here. These are the X or Y and Z planes, which you see on the drawing here. Here, these 2 lines, these 2 axes, Y and Z axis, it is on the figure what you see here. What I'm going to do is I will just orient my profile by using the buttons around here. I will use the button because I do not want to just get out of my profile sections. For here, I will use this point or this point to move to outside of our inside of our profile sketch. As you see, we have a profile here. It is oriented, as you see, from the left side or right side. And also we have this point to be on this line. Okay. The next thing, I will just, okay. When I just confirm my profile, here I have the frame file name. I will just delete frame assembly. The first one, we have the welded. This is the frame assembly. And also, this will be a file name. Here we have a file name, which is the lower profile here, the named. For here, I will just change the skeleton file name. For here, I will use lower profile. You can also change the folder properties here. You can also change the properties of our part or the saving locations. When I just click OK, I will approve everything on our profile. As you see, it is the display name. You can also change this one as for the display name, lower profile. When you just go for the other parts, it will be something like the profile name here. When I click OK, this is our part with part frame skeleton. Also, we have the frame assembly. We have the lower profile. Here, what I need is, I will just make the trims after I have just created other profiles by using the surface relationships. Okay, the next thing, I will save my part file with all properties. Here, what I'm going to do is, I will just create a side profile, 2 side profiles, which is this one and this one. Again, insert a new frame. The next, I will just use the same profile dimensions, but this time I'm going to use this endpoint. Let me let closer, or you can just make it and close the visibility of our figure. I will just open. This is our frame assembly. Insert it in the frame welded IEM assembly file. We have the skeleton here. I have just hidden the first profile, which is the lower profile, and I will just create two side profiles here. Insert a new frame, member, the same thing here, the same properties, the same ISO standard, the same family of the profile, the same size. You can also change the size as you wish. The steel material as the material appearance. Here, I will use the same thing. This time, I will just create a new profile between these 2 points, which is this one and this one. Okay, the next thing, this one and the other one is this point. We have two profile points, ending points. As you see, it is outside of our part sketch. And I would like to just adjust my orientation from here to the upside. I will just change my orientation because I would like to keep within the frame limits which I have seen here, because it just not goes out of our main frame triangle. If I use this orientation point, then I will just enlarge my profile, but I will use this insertion point and I'll just move my profile to lower side. And it will be an okay. And I will change my profile. I'm sorry. Again, insert the frame. Here, what I'm going to do is this one and this one, profile. Again, steel profiles. It's working. And the profile here, which is okay. I will rename this time the display name as you see here, which is the side profile, which I have in the technical drawing, the number 3 of this side profile. Okay. Okay. Our next move is, I will just again hide this visibility. Then I will just have insert a frame between these 2 points, this point and this point. Between these 2 points, I have a new frame. This is also a side profile. You can rename a side profile too. Okay. This is the side profile one. This is the side profile two. You can have these two names later here. As you see, we have the frames here. What I do is I will just make the endpoints trimmed, but this trim would be something like this. We have to, if I have just trim the profiles onto each other, I will have some parts open, and these openings will result a corrosion properties. For this, I would like to have this connection, which is called the miter connections here. I would like to have a sharp connection, and it is to be trimmed by using this intersecting edge, which you have seen here. I'm going to just create an intersecting edge, which is this one, between the points, the profile directions. I'll use that profile directions. Okay, I'll just zoom out, turn to my example here. What I'm going to do is I will just use this miter property. As you see in the definition of the miter property, which is this one, as you see, we have a connection property. It is to be trimmed as you see on the screen. Also here, I will use the miter property. In 3 points, I need the miters. We have the miter property here. I would like to have the intersection points. Also this point. This will result. I need 3 points, which is this point, and this point. I need 3 different miter properties. You can also, when you just select miter command, you can just release a gap between these 2 points, these 2 profiles. For this may be anything that you can select. Also for welding properties, the welded assemblies also have some gaps, needed gaps for welding properties, because welding is a process with the heat, and heat causes expansion of our profiles, and this expansion, this expansion just results a relief stress or stress on our frames. For this, we need sometimes the gap points. Also for manufacturing tolerances, it is a 10-meter profile, and you can just do not precisely cut the profiles as you wish, because it's a long way here. What I do is I will just select the first profile, then the other profile, and just to see the result of our selection. As you see, if it is 2, yes, it's okay. You can also change the bisect miter cut with the full miter cut. It depends on the profile which we are using. We have 2 equal sized profiles, then we do not use this one, also this one. With OK, I will just select and get the result here. Do the same thing for other 2 corners, which is this corner and this corner. I will just use the miter tool, select 2 profiles, which is this one and this one. I will just go with the command. Again, the next thing, yes, this profile and this profile to be cut and trimmed and adjust to each other. Okay, the next thing, we have 2 more profiles, 2 inside and 2 outside profiles, which is at the midpoint of our side profiles. Here, I will just first make these profiles to be hidden with visibility from the frame assembly. I will just select with control button all properties, and you can just use visibility, and again with control button you can just close the visibility of our profiles. I will save my part file. As you see, the frames are just saved as it is. You can also change the names as is if you want, so then I do not need to. This is only the representation. The part files are something different. Here, I will just insert this time a frame member from the top side and from the bottom side. This time, my connection, I would like to have my member frame to be oriented not sideways, not this way, not this way, I would like to have this orientation by using a center point here, as you see. For this, I will just choose the origin point to have my connection. For appearance, you can just change the appearance by using the length or other properties. These are the material appearances. You can also change the as it is, as the material. I will just create. You can also change, as you see, you can change the, I will change the inside profile with long one. You can also change the name if you want so. This will be our part file inside profile long. The other one we have just omitted to save here. One part will be enough normally. We have this profile. Also, we have another member, which is the symmetrical of these two parts. Here, what I'm going to do is I will just make a new part insertion. But before this one, I will just choose visibility close to see better of our starting and ending points. Again, I will use this point and this point. I have created, as you see, we have our orientation starting and ending point, which is the centered profile. I change the profile again inside profile long. To change the file name, you can also save inside profile long 2. But okay. We have this profile. We have two profiles left here. Visibility. I will just close. Again, two profiles on the lower left links. Again, I'm going to use the center point orientation. My profile starts from this point to this point. This is my part profile. It is created, as you see, which is, I will approve with OK. Inside profile short. This is the first one. I will use for renaming purposes also. This is the part file short one with OK. I'll just close visibility to change this one again and insert the frame here. Frame member from this point to this point by using this placement tool and with OK. Again, inside profile short 2, I will also rename my part file. This is the short 2 with OK. Okay, I will open all the profile visibilities which I have created so far, and I would like to just make and prevent the interference between each of the members here. What I'm going to do is I will just make trims. This time I will trim to be by using these two frames. Also, you can just use an extended frame tool. You can just extend as you wish. You can use the surfaces to extend, or the points to extend, or the lines to extend. Also, we have some other properties like the tools we have. Okay, the next thing, I will just make the trim. You can also use the miter tool first, then the trim first, as you wish. If you want, let's use the miter tool for these two profiles. Okay, as you see, it is just adjusted from inside, or you can just make the trims first. First, make the trims, and you can just use this trim tool, the face here. Then you can make the prevent the interventions, or you can also make the trims as you wish at later points. Okay, yeah, I'm just going to just select the trim tool, the miter tool first. I will adjust, then make the trims to all side here. I will just make the trims to adjust this intersection here, which I have seen at this point. Or you can just make the trims as you wish so. Okay. I will just close. And I will make the trim this profile by using a surface on our assembly. Let me change the profile appearances by normal solid color with gray. Okay. Also, I will just like to have the visual profile, visual style shaded with edges to see the profile endings as you see here. What I'm going to do is I will just go again, design, trim. I would like to trim this one, this profile, to up to this surface first. This is the surface, this is the face here. I will make this trim. As you see, my profile just trimmed to up to this point. I will just close with OK. It's going to have a calculation background here. Again, to trim this profile by using a face tool, and I would like to have that face, this face, up to here. Yes, you can also create a gap between the profiles. Let's exaggerate this gap here with 10 millimeter. I will just leave a 10 millimeter gap as you see here. If I use this gap by using this 10 millimeter gap tool. Okay. Of course, 1 millimeter or 2 millimeters will be enough for this gap. Okay. We first have this interference between these two profiles by miter tool, and we will have a trim profile around these two profiles here. The next, let's organize these tools here. I would like to have this frame by using to be trimmed by using the face on this point. As you see, it doesn't touch, these two profiles doesn't touch don't touch actually to each other. This is the trimmed tool here. What I do is I will just make a trim for other profile. This is the profile. This is the face with OK. Okay. The next, we have two profiles more to be trimmed. This is the profile and the face. What I'm going to do is this profile. This profile to be this face. With OK. Again, trim for this last profile. We have a frame member here, and it is to be trimmed by using this face. It is to be trimmed, as you see. It will just go inside of the side profile, then it is to be trimmed here. The next, again, to be trimmed. Then choose this profile, trim the selected part. Then here I will use this face to be trimmed with OK. This is our modeling part. As you see, we have a skeleton model. I will just save all my parts here. We have a skeleton model and our frame assembly just inserted to our frame here. When I change the frame sketch like this, for example, I will just double click of the frame here, or you can just open, for example, I will just change from the part drawing. I will go to and change my profile section. For example, I would like to have, instead of 2,500, I will just make it extended to 206,000 of this height. And I would like to have engage 10,000 millimeter base length to be extended to 11,000 millimeters. I will extend this one. The profile is just created on this sketch or on this frame skeleton. For this, when I save this part, my profile, as you see, it is just to be enlarged, but this is enlarged, but the frame just stays and it at its place. For this, the frame welded needs an update, local update and the part update. Also, the frame is going to be updated for the new modified frame skeleton. When I just click this one, the local update, it is just adjusting all the properties here. As you see, we again have the points of our frame here. And it is all the miter cuts and the properties all adjusted to each other. Here also we have some interferences. We may have some interferences when we just squeeze our frame folder, frame skeleton. For example, like this, I will just again adjust my line to 9,000, let's say. Also, I will just change to 1,200 millimeters in size. I will just a little make smaller of our frame here. For this, cutting points have to be considered according to your figure here. As you see on the background, we have just changed our skeleton here, and we have a frame welded needs to be updated from the local update. When I just press that one, it has to be again recalculated for the profiles which we have here, as you see. Sometimes we may have some design properties. In our design, we mostly use our sketch models, or you can just change, for example, this one to be just enlarged, not 30 degrees this time, 80 degrees or something like this. Let's say 50 degrees. I will just close. As you see, it's a symmetrical part here. We just create our frame to be adjusted by using the update tool here. As you see, our skeleton, since our skeleton changed, our frame assembly just follows to that one. I will use the scale frame to be just back in the design values, which is 10,000, 30 degrees, and 2.5 meters or 2,500 millimeters in length. I will use and save my part file. Okay. Put yes to all the properties. From now on, I'm going to just continue our part file or this assignment or this example by creating the technical drawing of our part files, and also the assembly files by using. So this is a very simple technical drawing. We will just recall all our parts to our technical drawing assembly here. Okay. When I update, I will just go back to my part file. I'll continue with the technical drawing after the update. Okay. Yes to all and save.